Right, in this video what I'm going to do is combine two of the four techniques you need for the more advanced differentiation work. I'm going to do a few questions which involve both the product rule and some standard derivative work in the same question. So technically this is going to a higher level than just using the product rule on its own or just using the standard derivative on its own. But as you'll see when we go through these questions, this type of question is usually fairly straightforward. So I'm going to do a number of questions quite quickly. For example, number one, let's take y equals x sine x. What we've got here, which is what you've got to spot, you have got a multiplication of two functions of x. You've got an x multiplied by a sine x function. Now don't be drawn into the fact that can you multiply the x by that x to get sine of x squared? No, you can't. The sine x function is separate to the x. So you got x multiplied by sine x, and we write that as x sine x. You would never write that as sine x, x, like this. You'd never write it like that, because you'd be tempted then, when you write it like that, to write that as sine of x squared, which is not the same thing at all. That means sine of x squared. So we don't do it like that. We always put the x at the front. Right, so in this particular case, the product rule, u is equal to the first function, x, and v is equal to the second function, sine x. For the product rule, you need to work out, so I'm going to go straight into it, du by dx. Du by dx is 1. You also need to know dv by dx. Well, standard result. You need to know that if you differentiate sine x, you don't need to prove it, you can just quote it. It's cos x from our standard result. We now go to dy by dx, and dy by dx comes from the product rule. You quote the product rule as a formula. And there it is, you learn that off by heart. We now substitute in these four things into the product rule, and if possible, simplify the answer. So u, that's x, times dv by dx is cos x. So you write x cos x, plus v, that's sine x. And you multiply it by du by dx, which is 1. So you're going to multiply it by 1. Now a little hint, if the sine x comes first, then you need to multiply it by something else like a 1 or possibly an x or an x squared or something. In this case it's 1. Put the 1 at the front, perhaps in a bracket, like so. So you're not tempted, because if you're writing it like this and you times it like that, you might be tempted to multiply those two things together to get the sine of whatever. So if that was a 2, sine of 2x, you might be tempted, when really the answer is 2 sine x. So be careful. Do not multiply those two together. The 2 multiplies the whole thing. Okay? If you're going to put the sine x first and then the other thing afterwards, then you should do this. Sine x, put it in a bracket and then times it by the 1 or whatever afterwards. And then that'll stop you timesing those two things together. Anyhow, back to what I was doing. So v, that was the sine x, times du by dx, that's 1, and I'll put the 1 at the front. So the answer turns out to be x cos x, and 1 times sine x is just sine x. At this point here, you should look at these two things and ask, can they simplify? Now sometimes this bit of algebra at the bottom will simplify. Things that you can look out for are, do they have common factors? Or if they've got trig terms in, can you use some trig work to somehow simplify them using some identity work? In this particular instance, there's nothing you can do to simplify them. So there's the answer, x cos x plus sine x. And that's the end of the question. Right, let's have a look at number 2. If I give you y is equal to, let's say, x squared cos x, and I say to you, differentiate that. Okay, in this case, you've got a product of two functions, x squared times by cos x. So u is x squared, v is cos x. So du by dx, which you need, will be 2x, and dv by dx, standard result you should learn, is minus sine x. You now write down the product rule. So dy by dx will be equal to u dv by dx plus v du by dx equals u, that's x squared, times dv by dx is negative sine x. Now really important, don't just put minus sine x like that. If it was x squared times a positive sine x, I would write that as x squared sine x, because that means x squared times sine x. But because it's a negative sine x, you need to put a bracket round it like that, because it's x squared multiplied by the negative sine x. If you only write it as x squared and then the minus sine x like that, that actually means x squared take away sine x. You need to have these things multiplied together, so I put the bracket in. Very important. So if it's a negative quantity, put the bracket in. Plus v cos x times by du by dx is 2x. Now once again, similar to the last example I did up here, if I'm going to multiply this by 2x, I would be tempted to put the 2x at the front. It looks neater. 2x cos x. Do not be tempted to put the 2x at the end and then put cos of x times 2x cos of 2x squared. That's not right. It's 2x cos x. Let's tidy this up. Right, well, that times that will give you negative x squared sine x, and then plus 2x cos x. Now that's the basic answer, but in this case we can simplify it by using a common factor. There's a common factor of x in both terms. And one more thing that I would do to make it look a bit neater inside the bracket is, that's a negative term, that's a positive term. I'd always put the positive first. So I would write 2 cos x first. That times that gives you positive 2x cos x. And then negative, this times an x sine x. That times that gives you that expression there. And you'll see that you've got an x outside, positive first, and the negative quantity second. It's just a neater way of writing it down. And there's your answer for that question. Okay, so I've done a couple now of basic product rule with standard derivatives for trig ones. Let's now do a third one, and I'll change the notation here just to make you aware of this. I'm going to say that the starting function, instead of y equals, the starting curve is f of x equals, and f of x this time is going to be, let's say, 2x tan x. Right, now that means that in this case, u will be 2x and v will be tan x. So you need du by dx, that's just 2. And now a standard result you learn off by heart, dv by dx is sec squared x. You learn it off by heart. We quote now the product rule. Now be careful, if y equals the curve, then dy by dx is the notation you use. But if the curve is given as f of x equals that, then when you're working out dy by dx, we actually call it f dash of x. So just be aware of that new notation, f dash of x, but the formula remains the same. So we quote the formula. And we substitute in. Okay, so u is 2x, times dv by dx is sec squared x. So 2x sec squared x. Don't need brackets there, that's fine as it is. Plus v is tan x. Now notice I've left a bit of space there to put the second thing. Times du by dx, which is 2. I'm not going to put the 2 at the end because you'd be tempted to put tan of 2x, which it's not. It's 2 tan x. Put the 2 at the front. Looking at this, simplify it. The best thing to do here is just to take out a common factor of 2. And you're left with x squared sec squared x sec squared x plus tan x. And there's nothing else I'm going to do with that. That's going to be the answer to that question. Simple as that. So even though it's a more advanced question, technically speaking, it's very easy to get to the answer. Okay, I'm going to turn over the paper and do a couple more now. Okay, so let's have a look at number 4. What about y equals, let's say, x squared e to the x? So an exponential involvement here. Again, a product, x squared, multiplied by e to the x. So u is x squared, and we'll need du by dx in a minute, that's 2x. V is the exponential e to the x. dv by dx, standard result, should learn it off by heart, is just the same thing. To get dy by dx, which is the notation for y equals, u dv by dx plus v du by dx. Substitute in the 4 things. U, x squared, dv by dx is e to the x. plus v, e to the x, times du by dx is 2x. I could put it in a bracket at the end, but I'd probably put it at the front like I did for the trig terms, so 2x e to the x. Simplify this. Well, there's certainly an e to the x in both terms, common factor. And there's certainly an x in both terms, so x goes outside, x e to the x. X e to the x times an x gives you x squared e to the x, plus x e to the x times a 2 gives you 2x e to the x. And there you go, there's the final answer, straightforward. Okay, let's do one with log involvement. Number 5. What about y equals, how about x log x? Okay, so in this case, a product of x multiplied by log x functions. So dy by dx is equal to, sorry, before I do dy by dx, I better work out u and du by dx first. U is x, du by dx would be 1. V is log to base e of x, so dv by dx will be equal to, well, standard result, learn it off by heart, 1 over x. Now we go into dy by dx, is u dv by dx plus v du by dx. Okay, so this is equal to, sub in, u was x, dv by dx is 1 over x. So it's x times 1 over x, plus v, that's log x, times by 1. Well, once again, don't put the 1 at the end, because it's 1 times the log x, or log x multiplied by 1. So I'll put the 1 at the front, 1 log x, or you put it in bracket if you want. So equals the x and the 1 over x. Well, x times 1 over x is just 1. The x's top and bottom, if you like, cancel with each other. So you get 1 plus, and then 1 times log x is log x. And there you go, there's the answer. X log x, when you differentiate it, gives 1 plus log x. And there's no common factor there, that's it. Simple as that. So very simple. I'm going to do one more very basic one. Let's have a look at this. Y equals e to the x sine x. So this time I've got a mixture of a product of two standard results going on. So u will be equal to e to the x. Du by dx is the same thing. And v will be equal to sine x. So dv by dx, standard result is cos x. So dy by dx will be equal to, dy by dx will be u dv by dx plus v du by dx. So u is e to the x, dv by dx is cos x, plus v is sine x, and then you times it by du by dx was e to the x. Now normally we put the e to the x at the front, it just looks neater. E to the x times sine x is better written like that. Don't put it at the end. Okay, looking at this, I hope you can see, this simplifies, there's a common factor of e to the x, leaving you with a cos x plus a sine x inside the bracket. And that's as simple as it will go. So there you go, I've got 6 very simple applications of product rule combined with standard results in the same sort of question.